In this video, I'll be doing CodeForces round 650 and explaining my solutions to the first three problems. Okay, so it's now long after the CodeForces competition. It is Friday today, and the competition was on Tuesday. So this was my first CodeForces competition, and I didn't do so well. In fact, I ranked 2,900 something, I think. Somewhere around that. Somewhere in the 2,000 range. So I only solved 3 problems. So let's go over the problems. Problem A, short substrings. Alice guesses the strings that Bob made for her. At first, Bob has a string A, and then he constructs the new string B so that Alice can guess the original string A. Bob builds B from A as follows. He writes all the substrings of length 2 of the string A in order from left to right, and then joins them up to make B. For example, if A is AB, AC, then all the substrings of length 2 are AB, BA, and AC. So the new string B is going to be AB, BA, AC. You're given the string B, and then help Alice guess the original string A. Time constraints are, or test case constraints are, there's going to be 1,000 test cases, and B is going to be at most of length 100. Here is my code. Basically what we do here, it's pretty simple. We basically take every other character in string B and use that to create A, because we know that each letter is going to be created twice, because it's a part of 2 possible substrings of length 2. The one that contains the character on the left and the one that contains the character on the right. Therefore, we're going to take every other character, since every character is repeated twice. But we always are going to take the first and last characters of B, because those are going to only appear once in A, because there's only one substring of length 2 that contains them. Therefore, we're going to take the first and last characters, and then we're going to take every other character in between. That is exactly what we do here. So it's a pretty simple problem, I think. Problem B, even array. You're given an array A of length n, which consists of non-negative integers. Array indices start from 0. An array is called good if for every element in the array, the index is the same parity as the element. This means that for every even index, there's going to be an even number there, and for every odd index, there's going to be an odd number there. In any move, you can take any 2 elements of the array and swap them. So find the minimum number of moves which makes the array good, or say that it's not possible. If it's not possible, return -1. So what we do here is we find the number of elements that are out of place. And an element is out of place if it's even, but it's in an odd index, or it's odd and it's in an even index. So we find these, and these have to be equal, because if they're not equal, then any number of swaps will always leave an even, more even out of place numbers or more odd out of place numbers, because swapping is only going to reduce each of them by 1. It's always going to keep the relative difference between the odd out of place numbers and the even out of place numbers. So we need to make sure that they're equal, and if they're not equal, then we return -1. But if they are equal, then we can just make all the swaps between the odd out of place numbers and the even out of place numbers, and that's going to give us a good array, because we're going to eliminate all the out of place numbers, and that means there's going to be no out of place, everything's going to be in place, and it's good. Yeah, and that is exactly what we do. Problem C, social distance. Polycarp and his friends want to visit a new restaurant. The restaurant has n tables arranged along a straight line. People are already sitting at some tables. The tables are numbered from 1 to n in the order from left to right. The state of the restaurant is described by a string of length n, which contains characters 1 and 0. 1 means the table is occupied, and 0 means it's empty. Restaurant rules prohibit people to sit at a distance of k or less from each other. So if there's a person sitting at table I, then all tables from I minus k to I plus k should be free, except for table I itself. So we have to find the maximum number of free tables that you can occupy so as to not violate the rules of the restaurant. So more formally, what is the maximum number of zeros that can be replaced by a 1 such that the requirement will still be satisfied? Basically, what we do here is we look at the distances between 1s. So we know that for every interval or every gap between seated tables, we can place some number of new people. So we can just take every pair of consecutive 1s and calculate the distance between them. Divide that by k plus 1 because each person seated in that interval is going to take up exactly k plus 1 tables. They're going to take the table itself and then the k tables after it. We don't have to consider the tables before it because that can be taken by the person before. And we also have to cover the edge case where there's going to be all zeros or there's going to be no 1 at the very beginning. What this means is we have to make sure that there can be a person sitting at the beginning and the person sitting at the end because we want this to be greedy. But we're always going to have to seat a person at the beginning if they can, and a person at the end if they can, because greedy, right? So, we basically just do a linear scan, finding the distances, and then for each distance, we calculate how many people can sit in that pair of consecutive 1s. So, I don't know, for my first CodeForces round, I wouldn't say it's that good. Even though this is Division 3, which is supposed to be the easiest division, I didn't do very well. I only solved 3 problems, but I don't know if I could have done better, because problem D is pretty difficult. I'm still not sure how to solve it, but okay, there is actually a tutorial. I didn't notice this. I'll read this later. Sounds like a good thing to read. So that's all for this video. Thanks for watching, and if you have feedback, please leave it in the comments. But this is my first CodeForces round. I'll be doing more in the future and making more videos about those. I won't stop doing Elite Code contests either until I say I'm going to stop, but I'm probably not going to stop anytime soon. So, yeah, thanks for watching, and I'll see you next time. Bye.